All right, so these are the notes for finding the a value from a table and from a graph. So let's go ahead and start by, it says, graph the parent function y equals x squared, which is going to be right here. So I gave you these values of -2, -1, 0, 1, and 2. Then it says, what is the value of a for the parent function? Okay, so we're just going to square each one. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay, so here's how I find that. I'm also going to graph it here. So 0, 0, 1, 1, 2, 4. So I'm going to show you the two ways to find the a value. All right, so for the first one here, when I'm looking at a table, I start at the vertex. So the vertex is not always in the center, but how do I know where the vertex is? Here's how I know. The pattern repeats. So the y value is 1, 1, 4, 4. Okay. So what I do is I start from the vertex and I see how much do I have to take to get from 0 or where the vertex is to the next one. So in this case, how do I get from 0 to 1? Well, I add 1 unit. So therefore, a is equal to 1. So a equals 1. For a graph, I do the same thing. I start at the vertex. So in this case, it's at 0, 0. I go right 1, and then I see if I go up 1 that it's there. So it took 1 unit to get up there. So that's how I get a is equal to 1. Okay. So let me go ahead and walk you through these examples and kind of show you the same way here. All right. So for number 1, it says fill the table with 3 highlighted points. Give the value of a for each of the following graphs. Okay. So for the first one here, I see, I'm going to start from the left. So that's 1, 0. This is 2, 1. And this is 3, 0. All right, if I was trying to get it from the graph, I would go right 1, and then I see it's going down -1, so I know that a is -1. Okay. If I wanted to do from the table, I put the vertex in the middle. So notice these are both 0. So how do I get from 1 to 0? That is -1. That's how you also get -1. All right, for the next problem, the same thing. Starting with the furthest left, so -3, 0 is the point they give us. Then they give us the vertex at -2, -2. You might want to put a V by there just so you know where the vertex is. And then -1, 0 is the next point they give us. So here I'll start from the table to get it. How do I get from -2 to 0? Well, I would have to add 2, so that means my a value is going to be a +2. If I wanted to go from the graph, I would go right 1. Always right 1, and then I go up 1, 2, and I also see that is +2, so the a value is the same for both. So it shouldn't change since they are the same. For number 3, from this one as well. So first point is -3, -1, and then we have the vertex at -2, +3, and then we have -1, -1. So this is the vertex right there. And once again, I always do from the table just because it's easier for me to see it. How do I get from 3 to -1? Well, I would have to take away 4. Okay, and over here, if you go right 1, you'll see that it's 1, 2, 3, 4 to get to that point, and it's going down, so that's still -4. Okay, for the next one, let's plot these points in here. So the first point they give me is at 2, -1. The vertex is at 3, 2. And once again, I know from the graph it's the highest or the lowest point, so the minimum or maximum, and 4, -1. So this is my vertex. If I wanted to do it from the graph this time, right 1, and then I can see I go down 1, 2, 3. So that should be -3. And to verify it, how do you get from 2 to -1? You take away 3. So what does the value of a do to the graphs? Well, it reflects it across the x-axis, so it flips it. And it also causes your graph to vertical stretch or vertical compress, right? Because your graph either gets wider or more narrow based on the a value. All right, so the next part of the notes. So now, what is the value of a? Now notice it's just the graphs here. Okay, so go through this pretty quickly here. Here's my vertex. So I'm just going to go right 1 automatically, and then as it goes up 1, so I can see that a is +1. For the next one, I start at the vertex, and I go right 1, and I go to where it intersects nicely, so that's 1, 2. I'm going down, so that's -2. Okay. Vertex we can see is right here at this point. We go right 1, and we see we go up 1, 2, so the a value is +2. For number 8, vertex is right here. And then we have right 1, and then we go down 1, which is negative 1. Okay, so this one has an equation here, but it doesn't tell me what to do. So let's say we do this one in, we'll do vertex form. So y equals ax minus h squared plus k. So we now know, so let's write the vertex. So the vertex is at negative 1, positive 2. And the a value is at negative 1. So when I plug it in, y equals negative 1. X minus, if I take negative 1 and plug it in here, it becomes positive 1 squared. And the k is positive 2, so plus 2. All right, for the next line, we'll do the exact same thing. So my vertex is right here. I go right 1, and then I go up 1, 2. So a is 2. So once again, vertex is going to be at 2, 1. And my a value is 2. Even though it's in there, I'd like to write it there. So y equals, so I'm using this equation here. Y equals a, which is 2. Parentheses, x minus h is positive 2. So when I plug it in, it becomes minus 2 squared. And that's a positive 1 for k, so plus 1. All right, so let's take a look at the next one here. And we'll continue with vertex form, and I'll switch it up in a minute, but let's just see here. Okay, so for here, first thing you want to do is when you're doing the tables, identify the vertex, okay? And I look at the y values. So I see negative 8 in the middle here, and I see this pattern repeats negative 4, 8, 8. So I now know that this is the vertex, okay? So from here, how do I get from negative 8 to negative 4? Well, I add 4 units to get there, so a is equal to 4. So once again, we're going to do this in vertex form. And my vertex here is negative 1, negative 8. And we said the a value is positive 4. So y equals 4, parentheses, x minus. So if I plug negative 1 in here, it becomes positive 1 squared, and then minus 8. Okay, for the next one. Once again, we have to find the vertex, and I see the pattern negative 1, negative 1. So if this is 8, it would be 4, comma 8 as well. So just kind of pointing that out there. And again, we'll do this one in vertex form again. So here, the a value, how do I get from negative 4 to negative 1? Well, you're going to add 3. Okay, so the a value is 3, and the vertex is right there. So now I'm not going to write it down because I can just see it. So a is 3, x minus 2 squared, and then the k value is minus 4. All right, so the next one we will do in intercept form. So y equals a x minus p x minus q. And the reason I picked intercept form for this one is because I can actually see one of the roots. Okay, so that's the reason why I picked it. Okay, so first we're going to still find the vertex. I see it's a negative 4, and the reason why negative 3, 0, 0, 5, 5, right? So this is the vertex. So how do I get from negative 4 to negative 3? Well, I just add 1. So now I know the a value is 1. Okay. So now I need to find my x-intercepts. So I need to find my roots. Where does it cross or touch the x-axis? Well, this one I can see is at negative 1, 0. It doesn't really matter if that's p or q. It doesn't make a difference. And we talked about the pattern repeating, right? So if this is negative 4, negative 3, negative 3. If this is 0, this must be 0. And this value is negative 5. So there's my second root at negative 5, 0. And we know the a value we just said was 1. Okay. So from here, we're going to plug it in here. So a is 1, so I don't write it. X minus, if I take negative 1, plug it in, it becomes positive 1. X minus, if you take negative 5 and plug it in, becomes positive 5. Question I always get is, does it matter the order? No, as long as you have the intercepts of x plus 1, x plus 5, doesn't really matter which one comes first. All right, let's take a look at number 13 now. So for 13, the pattern's pretty easy. We see it's right in the middle, so this is the vertex. How do you get from negative 12 to negative 9? Well, you would just add 3 units. So we know a is 3. And then I can see my roots. So here's an x-intercept, and here's an x-intercept. So I'm going to plug it into that formula. Y equals a, x minus p, x minus q. And I'm not going to write it down because I think you can start seeing it now. A is 3. X minus, so this is negative 2. So when I plug it in, it becomes positive 2. And then right here we have 2. Oh yeah, so that's x minus 2. All right. And now for number 14. So for 14, let's see. Okay, so I see the pattern negative 9, negative 9. So this is in the middle. That's the vertex. How do I get from negative 12 to negative 9? It's just like the previous one, it looks like almost. But I would add 3 again. So now I'm going to find my intercept. So -9, -9. If this is 0, this must be 0, and this is -3. So my roots are at 1, 0. So a value is 3, x minus 1, x minus, but this is a -3, so when I plug it in, it becomes +3. Okay, so there it is. And then now I saw this. 15 says write numbers 9 through 12 in vertex form, which you can see we did 8, 9, 10, and 11 in vertex form, and I did 12, 13, and 14 in intercept form. So yeah, that's pretty much it. Got those done. Have a good one.